okay? And actually, it's the force that keeps that penny on there is really the same force that keeps the marble in the track on those roller coasters, and it's actually the force that keeps a roller coaster on the track of a real roller coaster. So real roller coasters, they do have all kind of safety devices, like when they go through loops. If they if something were to malfunction, they do have like wheels that are going to hold it up on the track, right, so it can't flop off. But I wouldn't want to have to depend on that mechanical, something like that, hold it on the track. So it's really the force that's going to keep that, keep pushing it right through the loop. So you see, if I keep up the speed, it's mine's a little bit thinner. Okay, can you guys try that with you and demonstrate with your kids, your students? Steve's got a better coat hanger than I do because his is a little bit bigger diameter, so this is going to be a little easier. Okay, Mahendra, move these fingers in if you can. Okay. And I think it's better for you to, spin it around this way. Oops, I got this little setup. The trick will be to make sure these are all equal because I let the kids use this. Let's see. And even though this looks more dangerous, I'm gonna go back here just in case I slip up. Okay. I would like you all to try this, okay? And I think you're gonna be able to do this much easier than the coat hanger and the penny. Okay. So on the base here, I have just a line drawn for the center. So if you put that in the center, so oops, this is nice and straight. And just like the coat hanger, if you get a little bit of momentum, then you could flip it, spin it right around, okay? And then as long as you go nice and easy, that water's going to stay in the cup. Why, you guys? Why is that water staying in there?
Centripetal force.
Why doesn't the water dump out of the cup when it's either sideways or when it's right over my head? Right, it's with that momentum, the water just wants to keep going straight out, right? But it's this string and the base and then the cup that's holding the water in there. So it's that's creating that centripetal force that'll keep the water in there. Just fold it right in half, okay, so you can find the center without measuring. And then take a little piece of tape. Yeah, so stick it both sides. Stick that right, make this stick right where it's on the screen.
We will move your paper there.
Take it first. Okay, so now if you have tape on there now, you can just let this and make it kind of a natural curve, and it should be the same height on both sides. Okay, that is an experiment. Right? Yeah. And then we can put just like a little bit of tape here and a little tape here, just to hold it.
We're supposed to measure that 10 centimeters exactly?
Do we have to measure anything? 10 centimeters?
Yep, but first just actually not before you tape it. We'll just tape this just so it doesn't move.
And both should be
Both sides, yeah. So they're about the same distance down.
That?
Yeah, it wouldn't hurt if you tape just a little, just so we don't move on.
Well, it's
First experiment, and I just have one kid be the recorder, okay? And you kind of have to be eye level because if you're not, it's not going to work. These are marked at 10, 20, and 30, but it's kind of hard to eye where that is. So usually what I do is I have who's ever going to let the marble go. Start right at 10, okay? And Mahendra, if you put your ruler over here, and again, you're going to have to get kind of eye level, so maybe if you sit down so you can see. And you're just going to watch how high it goes. If I let it go at 10, okay, you ready? Okay. So if it was, if it didn't go high enough, you might want to go even over here a little, just so you can, because what you're going to try to do is see how many millimeters high or centimeters up high it rolls. Okay, so again, I'll try 10. Okay.
8.
Okay, so then for the first one,
just have the kids write A, and then, we're gonna do this 3 times.
Something 8.
8, okay. And, record it 3 times, and then write down the average. So do it at 10, then again at 20, which is way up here, and then at 30, okay?
So that's the first class, and we're gonna have them actually do the experiment. You try to have to make sure they put it in the same place each time. Otherwise, some groups might get a totally different result than somebody else, another team. Okay, but what I would take that, and look at the difference. Like if you wouldn't want to bend this all the way down. You want to try to have it so at least there's a little bit of a slope, so the marble's going to stay on there, something like this. But if you tape it right at the beginning of the loop, try to get it to follow that contour. Okay. Oh, and you know what? You guys, one huge thing I forgot to mention. Okay, you notice this is the 3M tape. Do you guys have the school smart tape? Yeah, that's school. Whatever that stuff is, we have school smart rulers, school smart pencils. It should be school rip-off stuff because it is like the absolute worst stuff. I would recommend with the roller coasters to use the better tape if you could, because if they use the cheap tape, by the time they make it to CPEP day, chances are the tape's going to be
It's
falling
worn
off.
out, okay?
Maybe using drafting tape.
What's that?
Maybe it's not masking tape. Maybe what it's telling you is drafting tape.
Well, it's weird. It just does not.
Drafting tape is like that, except for in time it will just peel right
Has
over.
run in the marks that says start because it is a different distance from the center point. Okay, so the starting point 1, which would be at 30 centimeters. Okay, and we're looking an
Do we
optimum.
have to put a tape here or no?
Yeah, no, you don't have to see because you're not watching a hike that's coming up. You're just seeing what's going to happen as it goes off that hill. Optimum would be like in that free fall where it's just barely wanting to lift off of that track. If it just kind of went slow, then that was kind of like that would be safe, but not like a real cool roller coaster. So you just call that a safe hill. But if it went flying off, bounced off, then you would call that unsafe because if that was a roller coaster car, people would probably be dead, right? So anyway, so at 30, okay. And now I notice these rulers, boy, they're not so good, are they? The see-through thing. But if you start at 30, now we're really watching what's going to happen over here. Okay, so at 30, okay, you might have to do it a couple times. Can you really see what's going on there? 30. It didn't. I don't think it hopped.
I don't know. It almost like it did, but I can't be positive.
Okay, kids might get different results. I don't think it did. That time it did.
Yep.
That time it hopped. So then with hill A at the starting height of 30, if it did hop, and I saw it hop that time, I would say that would be unsafe. I'll do it one more time. Yeah, it's hopping. Okay, so that'd be unsafe. Now, if it's unsafe at 30, you know what's going to happen at 20. It's going to be safe, right?
Yeah.
Okay, and then 10, who knows? Maybe it'll have like a rollback thing almost. And that is one thing. That real roller coaster enthusiasts, that's what they love is rollback, and that happens sometimes. Like even on that King Dakar, that super high fast, 128 mile an hour roller coasters. Occasionally, because you figure it's got that hydraulic to launch it just at that beginning. Then after that, it's when it's no longer under that power, it's coasting to the top. But if it either hits like high winds or maybe even a lot of friction, sometimes, and that's part of the thrill, it looks like it might just barely peter out before it goes over that hill. And occasionally it does, and it rolls back, and it's designed, if it does get stuck in the low spot, then it'll go back to, its starting point. So that's cool. But anyway, so for this, so you're going to list either optimum, safe, or unsafe. And you can imagine hill A, if it was unsafe at the height of starting height, look what's going to happen when you do like a hill like this, B, and then even a shorter one, C.
Yeah.
Okay? So that should be pretty cool, and it'll take you a few. Yeah, the center line of A would have to be in some line for experiment.
Ten. It's a rollback or what is it?
Have you guys started?
No, we have to be.
We're kind of stalled.
But he really wants to do it.